Every great discovery begins with a question, and every answer begins as a theory. What theories explain space-time? How do they predict the fate of matter? From Einstein's elegant equations to quantum whispers of the smallest scales, physicists have built ideas that reshape reality itself. Today, we explore those theories, the pillars of modern cosmology. Einstein's general relativity is the cornerstone. It says gravity is not a force pulling objects. It's the curvature of space-time itself. Massive bodies bend a fabric, and matter moves along those curves. This theory explains why planets orbit stars, why light bends near galaxies, and why time slows near black holes. So the key theory, general relativity, Einstein 1915, suggests space-time curvature governs motion and time dilation. Zoom in far enough, and Einstein's smooth fabric becomes frothy, quantum foam. Quantum mechanics predicts that empty space is never truly empty. Particles flicker in and out of existence, creating a jittery foundation beneath reality. Key hypotheses are quantum foam, John Wheeler, which speaks of space-time fluctuating at Planck scales, and quantum gravity, loop quantum gravity, string theory, which attempts to unify relativity and quantum mechanics. Stephen Hawking revealed black holes radiate heat, Hawking radiation. This means they evaporate over eons. Here, gravity meets entropy, and matter becomes pure information. Some theories suggest the universe itself may be holographic, with every particle encoded on a distant surface. Key theory for black hole thermodynamics is Hawking radiation, which suggests black holes emit thermal radiation, and holographic principle speaks of information about matter may be stored on a 2D surface. Einstein and Rosen imagined wormholes, bridges through space-time. Could they exist? Maybe, if exotic matter stabilizes them. White holes, they're theoretical opposites. We eject matter instead of swallowing it. These ideas remain speculative, but they push the boundaries of what space-time might allow. The key hypotheses for wormholes and white holes are Einstein-Rosen bridges, mathematical solutions in relativity, and white holes, hypothetical time-reverse black holes. In 2015, LIGO detected gravitational waves, ripples in space-time from colliding black holes. These waves confirm Einstein's vision and open a new window into cosmic events. Through them, we hear the universe's most violent symphonies. The key theory is gravitational waves, predicted by general relativity, confirmed by LIGO. Every idea we explore today began as a theory, a bold attempt to explain the unseen. From relativity to quantum gravity, these frameworks guide our understanding of space-time and matter's ultimate fate. Theories are not guesses. They are maps of reality, drawn from evidence and imagination. If this journey sparked wonder, share it. Subscribe for more explorations into the ideas that shape the cosmos.